And I'd like to finish this presentation with the last rule, the so-called basis rule. And basis rule is based on the basis theorem, which involves converting an unknown conditional probability, say the probability of event A given that that event B has happened, to one involving a known conditional probability, say the probability of event B given that event A has happened. And here is a formula for you. So the probability that event A happens given that event B has happened is equal to, so in the numerator we have the conditional probability that event B happens given that event A has happened multiplied by the probability of event A, and we divide this product by the sum of two elements. So first, the conditional probability of event B given event A has happened multiplied by the probability of event A, and the second element is the probability of event B given that the complementary event A has happened multiplied by the probability of the complementary event A. And to better understand this theorem, let's have a look at some specific example. So let's assume that there is a blood test that is 99% effective in detecting a certain disease when the disease is present. However, the test also yields a false positive result for 2% of the healthy patients tested. So that is, if a healthy person is tested, then with probability of 2%, the test will say that the person has the disease. So the test makes a mistake. And suppose that 0.5% of the population has this disease, and we need to find the conditional probability that a randomly tested individual actually has the disease given that his or her test result is positive. So we need to find the probability that a person has the disease and the test shows this disease. So let's define some events. So event D, this will be this will represent a person having the disease. So event that a person has the disease, and event E is that the test is positive. So from this description, we know the probability of a person having a disease. It's 0.5% or 0.005, because we know that only 0.5% of the total population has this disease. So therefore, the complementary probability of event D would be just 1 minus 0.005, so 0.995. We also know some conditional probability that given that a person has a disease, the test shows a positive result. So, or in other words, what is the probability that a test is positive given that a person has a disease? So the test doesn't make a mistake, is 0.99, and we know this from the very first sentence of this description. And we also know another conditional probability of a test being positive given that a person does not have a disease, so when a test makes a mistake. And we know this from the second sentence, 2% of the healthy patients tested. So false positive result for 2% of the healthy patients tested. So a person is healthy, but the test is positive. The probability is 2% or 0.02. Given this information, we just substitute everything into the formula. So the conditional probability that a person has a disease, given that the test is positive, is here in front of you. So when we put all the numbers into the formula, we get that the probability is 0.199. So there is approximately a 20% chance that a randomly chosen person from the population who tests positive actually has the disease. So based on this result, we can conclude that maybe this test is not that perfect.